In this part and the next part, we will use the NRCS Surface program to simulate evaluation and design of surface irrigation, which includes the basin irrigation, border irrigation, and furrow irrigation. In this part, we will deal with problem 1 for designing the basin irrigation as follows.
Problem 1, basin. The basin data comes from an 80,000
meter square
field irrigated by a canal water supply limited to 150 liters per second over a 96-hour period. The soil has a 6-hour intake rate of 0.95 inch per hour, which is typical of silt loam soil. The gross depth of irrigation GDI is 10 centimeter. The slope is 0.0005 meter per meter. The group and surface condition is cereal groups.
Now we will start solving this problem as follows. Solution.
The height of basin ridge equal gross depth of irrigation GDI, which equal 10 centimeter, and the maximum depth of flow in basin equal gross depth of irrigation minus 5 cm, which equal 10 minus 5 and equal 5 centimeter. Average depth of flow in the basin equal max depth multiply by 0.8, which equal 5 multiply 0.8 equal 4 centimeter. Then we go to manic equation calculator in NRCS Surface.
We go to the NRCS Surface program. Surface irrigation evaluation, design and simulation, which include the file, input, output, units, simulate and design menu. We press on the design menu and in it we go to the field topography over geometry menu, and in it, in the field system, we choose border over basin irrigation. Then in the flow cross section, we specify the options as we see. Then we go to the manic equation calculator, and in it we input the slope value for this problem, which is 0.305. Then we press on the tab key Then in the manning n, we specify this value from the table according to the group and surface condition, as we see. Then to complete the calculations in this calculator, we need either the flow in liter per second, or depth in meter, or area in meter squared. In this problem, we have the flow depth, which is 4 centimeter. So in the Manning equation calculator, for the depth in meter, we type 0.04. Then by pressing on the tab key, the results appear as we see. Note there is an error in the slope value, which is 0.405 and not 0.305. So we repeat the calculation in the Manning equation calculator as we see. Then the flow value becomes 0.3308 liter per second per meter, as we see. Then after we find the flow discharge per unit width, we find
field width for one irrigation ويساوي which equal total discharge over discharge per unit width equal 150 over 0.3308, which equal 415, which is greater than 400 meter. Then we take field width equal 400 meter. The field width or basin width. Then the field length or basin length equal total area over field width, which equal 80,000 over 400, which equal 20, which equal 200 meter. Then the Z-rate equal net depth of irrigation NDI over unit width,
and the Z rate is extracted on a volumetric basis, which equal to 10 over 100, which equal 0.1. Now, after we making the calculations for this basin or field, we go to the NRCS Surface program, and in it we input the data and parameters for the problem 1 for designing the basin irrigation. In this part, we content by making these calculations for the field or basin dimensions, and we will input the data and parameters of the basin dimension for the problem 1 for designing the basin irrigation in the NRCS Surface program in the next parts.